Hello students, welcome to Shri classes. We'll start a new chapter, that is chapter number 8, trigonometry, lecture number 1. This is quite interesting chapter. There are a lot of numericals and one has to solve. See, in trigonometry the practice makes you perfect, that you have to remember. So let us begin the chapter trigonometry. So what is this trigonometry all about? Trigonometry, it is derived from, this word trigonometry, it is derived from Greek words. Tri meaning 3, gon means sides, and metron meaning measure. Measurement of 3 sides of a triangle, meaning basically trigonometry, even though you can read something like this, measurement of 3 sides of a triangle, actually speaking, this trigonometry deals with the study of relationship between angles and the sides. So trigonometry is the study of the study of relationships between sides and angles of a triangle. So how this word has come into picture? Trigonometry is derived from Greek words. Tri means 3, gon means sides, and metron means measure. Measurement of 3 sides of a triangle is referred to as trigonometry. In fact, this is that branch of mathematics which deals with the study of relationships between the sides and angles of a triangle. That we need to keep in mind. Then comes, what are trigonometric ratios? T ratios, trigonometric ratios. Trigonometric ratios. What are these trigonometric ratios? So trigonometric ratios, generally these are the ratios of sides of a right triangle with respect to its acute angles. These trigonometric ratios, generally we call them as T ratios. T ratios are T ratios of the angle I'll write, that is preferable, because T ratios refer to a particular fixed angle, acute angle in a right triangle. T ratios of, or how it is defined, ratios of sides of a right triangle with respect to its acute angles are called trigonometric ratios of the angle. T ratios, ratios of sides of a right triangle ratios of sides of a right triangle with respect to its acute angles ratios of sides of a right triangle with respect to its acute angles are called trigonometric ratios. ratios of the angle or angles, ratios of the angles. So these are the definitions, not required. All this is only just to understand what do you mean by trigonometric ratios and how this word trigonometry has come. And basically this is the study of relationship between the sides of a triangle and its angles. And especially in your 10th standard chapter, the trigonometric ratios refer to the ratios of sides of a right triangle. Here important, we are considering the right triangle. This is important. The ratios of sides of a right triangle with respect to its acute angles. With respect to its acute angles are called trigonometric ratios of the angles. So can we study now the trigonometric ratios of a right triangle? Let me draw that right triangle and then we'll start with the T ratios. The T ratios are generally abbreviated, like sin theta, cos theta, tan theta, or sin A, cos A, tan A and all, etc. So the full form as well as the abbreviated form of the ratios of the abbreviated form and the full forms of different trigonometric ratios we'll see now, and how to remember those ratios also in terms of the sides. So to begin with these things, nothing to be noted down here. Let me start with T ratios, trigonometric ratios of acute angles. Generally these trigonometric ratios are referred to as T ratios. Okay, whenever I write T ratio, don't get confused. These are trigonometric ratios. Ratios. First I will draw a right triangle. Let us consider a right triangle. Right angled at B. Let this be A, B and C, and this is right angled at B. Can you identify the perpendicular and base in this diagram? AB and BC and AC, there are three sides for a right triangle. Can you be able to identify the hypotenuse, base and perpendicular? Let us put some effort. Hypotenuse is the largest side of a right triangle and it is opposite to right angle, and therefore opposite to B, the side is AC and AC is called hypotenuse. Capital H, let me represent it by capital H. What about the other two sides? The other two sides, which is the perpendicular and which is the base? Some of you are thinking now, AB is a base and BC is a perpendicular. Some of you are thinking, why can't BC should be a base and AB a perpendicular? See, there are a couple of terminologies: perpendicular, base, one set, and similarly opposite side and adjacent side. Unless we define an acute angle, it is not possible to identify which is a base and which is a perpendicular. Similarly, which is adjacent side and which is opposite side. I hope you are able to understand what I am talking about. Here, if I put the reference angle as one of these acute angles, then I should be able to define the base and perpendicular. Let us consider this angle is the reference angle theta. Theta, it is represented by theta. This is the reference angle. With respect to this reference angle theta, AB is called adjacent side or base, and BC is called perpendicular or opposite side. With reference to theta, AB is called adjacent side because it is adjacent to theta. AB is called base because it is adjacent to theta, next to theta. Whereas BC is called opposite side because it is opposite to angle theta. And similarly, BC is called perpendicular. So, if I know theta, that is one of the acute angles of a right triangle, either A or C, then it is possible to identify adjacent side and opposite side. First, I go by the terminology adjacent side and opposite side, and then what are the similar analogies for in terms of perpendicular and base. That way I can proceed. Theta is the reference angle, and therefore adjacent to this theta is the side called adjacent side. Adjacent side. A, let me mark it. And opposite to theta is called opposite side, which is BC here. Opposite side. What is the base and perpendicular? Adjacent to theta is the base, or adjacent side itself is called a base, and this is called a perpendicular. Opposite side can be called as O or perpendicular. Perpendicular. It is called perpendicular. I hope this terminology you are able to understand. If reference angle is theta, adjacent to theta is adjacent side, opposite to theta is opposite side, adjacent side is called a base, and opposite side is called a perpendicular. I hope you are able to understand this. Perpendicular is represented by P and base is represented by B. Here B, I'll write it. Is this terminology clear for you? Let me demonstrate a couple of examples over here. Let me take, okay, this is theta here, this is A, B and C. Reference angle is theta, reference angle is theta. With respect to theta, reference angle, which is an adjacent side and opposite side. AB is adjacent side, which is also called the base, and opposite to theta is AC. AC is called opposite side, which is called a perpendicular. What is hypotenuse? This is right triangle, and therefore this is AC is the hypotenuse. Hypotenuse, perpendicular and base. In terms of, see here, base and perpendicular form one set. Similarly, adjacent side and opposite side forms one set. We read adjacent side and opposite side and hypotenuse as one set of representations of the triangles and methodology of reading. Another set is hypotenuse, base and perpendicular. This is how we read it. If I use adjacent side, then opposite side is the one that is to be used in terms of the terminologies of the right triangle sides. I cannot club adjacent side with perpendicular and all. It is not good also. So opposite side, adjacent side, hypotenuse forms one set of mentioning of the sides of a right triangle. Similarly, base, perpendicular and hypotenuse forms another set of naming of the three sides of a right triangle. In this case, if theta is the reference angle, opposite to theta is the perpendicular, adjacent to theta is the base. Similarly, this is opposite side and this is adjacent side. Now, in this case, ABC with respect to A, what are the opposite sides, adjacent sides and hypotenuse? With respect to A, because this is the reference angle over here, A with respect to A, hypotenuse is AC. Let this be 90 degree because opposite to right angle is hypotenuse and angle A is the reference angle. Therefore, this is adjacent side and this is opposite side. Similarly, this is a base here and this is a perpendicular. Base, adjacent side is called a base and opposite side is called a perpendicular. If I change this as the reference angle to this one, if I change this as the reference angle theta or angle C, then this will become the adjacent side and this will become the opposite side. This will become the base and this will become the perpendicular. I hope you are able to understand very well how to identify opposite side, adjacent side and hypotenuse with respect to the reference angles. Always hypotenuse is opposite side of the right. Opposite to right angle is called hypotenuse. After that, if I know the reference angles, then only it is possible to fix adjacent side and opposite side, or for that matter a base and a perpendicular. If you do not know the reference angle, in that case see here, B, A, C. Now can you identify A and let it be right angle? Can you identify which is a perpendicular and base here? If this is a perpendicular, this is a base and this is of course hypotenuse fixed. Or if this is a base here and this is a perpendicular. And therefore, in order to identify perpendicular and base, or for that matter opposite side and adjacent side, we must know the reference angle. What are those reference angles? In right triangle, there are only two reference angles. Those are acute angles. If this is the right triangle with right angle over here, this angle and this angle are the reference angles. Any one of that can be a reference angle. If the reference angle is fixed, then adjacent to reference angle is the adjacent side, opposite to reference angle is the opposite side. I hope you are able to understand the terminologies of this right triangle with respect to adjacent side, opposite side, hypotenuse, or base, perpendicular and hypotenuse. Clear? If this is clear, let me proceed with trigonometric ratios. I thought of drawing a little bit bigger diagram and mention these things clearly and list down the full form one side, trigonometric ratios on one side, and abbreviated form another side, and how to remember. Okay, so I'll draw the diagram and then we'll start with trigonometric ratios. Let us start with the trigonometric ratios. We have considered a right triangle here. This is a right triangle at ABC, right angled at B, and theta is the reference angle. With respect to theta, AB is the adjacent side, adjacent to theta is adjacent side, opposite to theta is opposite side, and adjacent side is also called base and opposite side is also called perpendicular. So let us list down the trigonometric ratios now. T ratios. There are 3 plus 3, 6 trigonometric ratios. And what are those ratios? Let us list down. The T ratios are: the first one, sine theta, SINE, sine, this is theta over here, okay. It is not the multiplication of sine and theta here, it is called sine theta. Sine theta equals opposite side by hypotenuse. Opposite side divided by hypotenuse, which is also perpendicular by hypotenuse. P perpendicular by hypotenuse. P by H, I can say. This is O by H, or opposite side by hypotenuse, which is nothing but perpendicular by hypotenuse, which equals BC by AC. So sine theta is BC by AC. Second trigonometric ratio. Cosine theta equals adjacent side by hypotenuse. Adjacent side by hypotenuse, which is also the base by hypotenuse, which equals AB by AC. Third one, tangent theta. Tangent theta equals opposite side by adjacent sides, which also is equal to perpendicular by base. Perpendicular by base, which is BC by AB. BC by AB. These are the 3 T ratios, and another 3 ratios are the reciprocals of sine theta, cosine theta, tangent theta. Here please remember, theta is the reference angle. Instead of sine theta, I can also consider this as A as a reference angle. If A is the reference angle, in that case sine A equals opposite side by hypotenuse, cos A equals adjacent side by hypotenuse, and tan A is equal to opposite side by adjacent side. See, according to your textbook, the terminologies that are used to define these T ratios are hypotenuse, adjacent side, and opposite side. But you must also know the alternate names for adjacent side and opposite sides respectively as base and perpendicular. And therefore, these trigonometric ratios in terms of the base, perpendicular, and hypotenuse also you must know that. Okay. So sine theta, cosine theta, tangent theta. Next is the reciprocals of these 3 ratios. Fourth one, the reciprocal of sine theta is called cosecant theta. COSECANT, cosecant theta, which equals the reciprocal hypotenuse by opposite side. Hypotenuse by opposite side, which is also nothing but H by P. In terms of hypotenuse and perpendicular, hypotenuse by perpendicular, which equals, take this one, hypotenuse by opposite side, that is AC by BC. AC by BC. Similarly, the reciprocal of cosine is secant. What is the reciprocal of sine? Cosecant theta. Similarly, reciprocal of cosine is secant theta. Fifth one, secant theta, which is equal to hypotenuse by adjacent side, which is equal to h by b, hypotenuse by base. Hypotenuse is AC by AB. AC by AB. Last one, fourth one, sixth one, not fourth one, sixth one, tangent cotangent. Cotangent theta equals reciprocal of tangent theta, adjacent side by opposite side. Adjacent side by opposite side, which is also equals B by P, that is base divided by perpendicular, which is AB by BC. AB by C. So these are the 6 T ratios. These are the 6 trigonometric ratios. So there are some abbreviated forms. The abbreviated forms, I'll write it here itself with red letters, red ink. Okay. So generally sin theta is referred as sin theta, sin theta. Abbreviations I am writing now. See, dear students, abbreviations I am writing here into bracket here. So let us see. Sin sine theta is written as sin theta. Sin theta. This is sin theta. And cosine theta is written as cos theta. Cos theta. Okay. And tangent theta is written as tan theta. These are abbreviations. And cosecant theta is referred to as cosec theta. COSEC, cosec theta. Secant theta is referred to as sec theta. And cotangent theta is referred to as cot theta. Cot theta. So red letters written in red letters are abbreviated forms. ABBREVIATED. I hope so. I hope you understand what I am writing. Abbreviated forms. Abbreviated forms of trigonometric ratios. Henceforth, we are using only the abbreviated forms of these trigonometric ratios. Sin theta is opposite by hypotenuse, and cos theta, sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. This is the sequence: sin, cos, tan, cosec, sec and cot. Abbreviated forms. Is it correct? The spelling may be correct. Okay. Now sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. We are not using the expanded forms, something like secant theta, cosecant theta. We may pronounce like that, cosecant theta, but while writing we use only the abbreviated form: sin theta, cos theta, tan theta, cosec, sec, cot. Now, how to remember this? For the beginners, how to remember this is a question, and therefore let me list down 2 ways here. Let me list down a couple of ways to remember this. Where should I write this? Probably here. How to remember this? sine ratio, cos ratio, tan ratio, and their reciprocals, respectively their reciprocals. One way of remembering this in terms of adjacent, hypotenuse and opposite side is sine cos tan O Anjaneya O Har Har Anjaneya. This is how I remember. Sine theta opposite by hypotenuse, cos theta adjacent by hypotenuse, tan theta opposite by adjacent side. Similarly, cosec theta or cosecant theta or cosecant ratio I am talking about, cosecant theta hypotenuse by opposite side and secant theta hypotenuse by adjacent side, hypotenuse by opposite, hypotenuse by adjacent and adjacent by opposite. So how to remember? O Anjaneya O Har Har Anjaneya. Sine theta opposite by hypotenuse, cosecant theta hypotenuse by opposite, cos theta adjacent by hypotenuse, sec theta hypotenuse by adjacent side, tan theta opposite by adjacent, cot theta adjacent by opposite. So this is how one way I can remember in terms of opposite side, adjacent side and hypotenuse. So O Anjaneya O Har Har Anjaneya. Next, in terms of the remembering the perpendicular base and hypotenuse, we try to remember by something like this. Sine ratio, cos ratio, tan ratio and the respective reciprocals. Pandit Badri Prasad Har Har Bole. Pandit Badri Prasad Har Har Bole. Sine theta perpendicular by hypotenuse, cos theta base by hypotenuse, tan theta perpendicular by base, cosec theta hypotenuse by perpendicular, sec theta hypotenuse by base and cot theta base by perpendicular. So Pandit Badri Prasad Har Har Bole, that is to remember in terms of base, perpendicular and hypotenuse. O Anjaneya O Har Har Anjaneya, that is to remember the T ratios in terms of adjacent side, opposite side and hypotenuse. So you must note down this in your first page very clearly, the full form of the trigonometric ratios and the abbreviated, which I have written in red and in square brackets, the abbreviated forms of T ratios. Henceforth, we will be referring to all the trigonometric ratios only in abbreviated forms. So as I said, in a right triangle, all these trigonometric ratios are defined only with respect to the reference angles. If you do not know the reference angles, which are basically the acute angles of a right triangle, it is not possible to identify the sides. Did you understand over here? If reference angle is theta, only in that case the sine theta would be, here this is theta I am talking about. If the reference angle is theta, which is nothing but angle A over here, only with respect to this angle A, sine will be, sine ratio or sine of angle A or sine of theta, angle theta should be equal to opposite by hypotenuse. If I reverse this theta to over here, definitely the opposite and adjacent sides also will get reversed. And therefore, please remember the trigonometric ratios are the ratios of the sides of right triangle with respect to its acute angles. Meaning, the trigonometric ratios are the expressions that define the relationships between the ratios of the sides with respect to the acute angles. Okay, these are all acute angles. This theta, A and C are the two acute angles. Why these are called acute angles of this right triangle? Because in a right triangle, if this is 90 degree, definitely these two are complementary angles. Are these complementary angles? If this is 90 degree, some of these two also should be complementary. That means individually these two angles should be less than 90 degree, isn't it? Each angle should be less than 90 degree, and therefore these are acute angles. Okay, I think that's fine. Anything with respect to the ratios? O Har Har Anjaneya, Pandit Badri Prasad Har Har Bole. This is how we can remember. So sin theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent side, cosec theta is hypotenuse by opposite side, sec is hypotenuse by adjacent side, and cot is adjacent by opposite side. Okay, so note down these t ratios. We are ready to solve the numericals now. Please note down. We'll start the numericals now. This can be randomly, I am picking it from R.D. Sharma as well as your textbook. So this is the example sum over here, example number 1 of your textbook. This is if tan A equals 4 by 3, find all other t ratios. If tan A equals 4 by 3, then find all other t ratios. What are t ratios? Trigonometric ratios. You do not write only short form, okay? Don't write short forms. All this is trigonometric ratios. Here I am taking a little shortcut over here. If tan A equals 4 by 3, then find all other trigonometric ratios. See, in order to solve such numericals, you must draw a right triangle and mention the respective sides as the given values, and then use Pythagoras theorem to find out the third side, and then you can find out the ratios, trigonometric ratios of all other sides. So how to solve such problems? There are two ways which I will show over here. One is R.D. Sharma method, R.S. Agarwal method, both are same, and another method is your textbook method. Of course, both all these are same only, कुछ फर्क नहीं है as such, but let's see what are these methods. So tan A equals 4 by 3 is given. Let me draw the diagram. Solution. Okay, let me draw the diagram first. This is a right triangle, right angled at B. I will take. Why I am taking B as a right triangle? Because angle A I would like to make it as a reference angle, because trigonometric ratios are always defined with respect to the reference angle. Therefore, this side I will mention A, B, C. This side is A, and tan A equals 4 by 3 given. Tan A equals 4 by 3 implies what is tangent A is equal to. So in order to remember this, I am writing over here O Anjaneya O Anjaneya O, Har Anjaneya. This is sine ratio, cos ratio, tan ratio, and the reciprocals. Similarly, here I will write Pandit Badri Prasad Har Bole. Okay, sine, cos, tan, and their reciprocals. Now, what is given to us? Tan A equals 4 by 3. So tan of A equals 4 by 3, meaning what are the sides with respect to reference angle A in terms of tan ratio? So tan of A is equal to opposite side by adjacent side. So see, remember, this is the reference angle. Adjacent to the reference angle is AB, and therefore AB is called adjacent side. Opposite to reference angle is side BC, and therefore this is called opposite side. Tan ratio is, here you can say, opposite side by adjacent side or perpendicular by base, and therefore tan A equals BC, opposite side, divided by AB. Opposite side by adjacent side. This is BC by AB. What is the meaning of this one? 4 by 3 equals BC by AB implies BC equals 4 units and AB equals 3 units. 3 units. And therefore, by Pythagoras theorem, I will write this one 3 and 4 units over here. What is BC? BC is 4 units. Where is BC? This one, 4 units. And AB is 3 units. Okay, 3 units over here. For my information, I am writing. Okay. And by Pythagoras theorem, can I find out the third side? Yes, possible. By Pythagoras theorem, EC square equals AB square plus BC square, which is 3 square plus 4 square, which is 9 plus 16, which is 25 AC square, and therefore AC equals under root of 25. Plus or minus will be there, but the sides of the triangle are scalar quantities, the lengths basically, and therefore I have to consider only the positive value. Therefore AC equals under root of 25, which is 5 units. So this is 5 units. You can see here 3, 4, 5 are the Pythagorean triplets. Are these Pythagorean triplets? 3, 4, 5? Yes. Now I have found out AC as 5 units. I can take all the trigonometric ratios now. See, in order to find out all trigonometric ratios, most important thing is we should know all the sides, the dimensions of all the sides. Here they have not given any units of measurements, and therefore this being the ratios, tan A equals 4 by 3 being ratio, I can consider to be units, and therefore I have got AC as 5 units. Now let us find out all other ratios. Other T ratios are trigonometric ratios are, first one, sine theta, not theta, sine A, because tan A is given, sine A we have to find out. Sine A equals opposite by hypotenuse, BC by AC, which equals 4 by 5. Now cos A equals adjacent by hypotenuse, AB by AC, which equals 3 by 5. Tan A already given to you, not required to be found out. The next is the reciprocals of sine, that is cosec A. Cosec A. What is cosec A? The reciprocal of sine A, that is AC by BC. AC by BC, which is nothing but hypotenuse by opposite side. AC by BC, which is 5 by 4. Sec A. Sec A equals, sec is the reciprocal of cos, which is hypotenuse by adjacent, AC by AB, AB here, which is 5 by 3. Sine, cos, cosec, sec, cot. Cot of A, cot is cotangent. So cot of A is the reciprocal of tan, which is AB by BC, adjacent by opposite BC, which is 3 by 4. 3 by 4. So these are the T ratios. What is the alternate method to find out all these things? This is RDS method. What is this the method? Here I'll write RDS, and of course RDS also sometimes use textbook method, not it's okay. This is RDS and RSA. These people do solve these problems like this. What about the textbook method? Let us see the textbook method. Textbook method. Let's see. Not much difference. Given, of course, diagram as it is, or for your information, let me draw a diagram once again. Here, angle BAC. This is right triangle. Given tan A equals 4 by 3, which equals tan A equals 4 by 3 means opposite by adjacent side, BC by AB, implies, or you can see here let BC equals 4K. You can write units also, or simply you can say let BC equals 4K. Therefore AB equals BC equals, let BC equals 4K, and therefore AB equals, let BC equals 4K, therefore AB equals 3K, where K is a positive, what he takes, K as a positive number or positive constant? Positive number, where K is a positive number. Positive number. And therefore, let me mark these things. BC is 4K here, and AB is 3k. Let me find out AC by Pythagoras theorem. By Pythagoras theorem, AC square equals AB square plus BC square, which is 3k the whole square plus 4k the whole square, and therefore AC square equals 9k square plus 16k square, which is 25k square. Therefore AC equals under root of 25k square, which is 5k, and therefore I'll write over here 5k. Always after drawing the diagram, it is preferable to write all the three sides in terms of either k in that diagram or simply those numbers as the ratios. It is preferable, so that while taking the ratios from the diagram itself, you should be able to populate the respective values of the sides. Now instead of 5 over here, I have got 5k because I assumed here BC to be 4k, and therefore AB equals 3k, and hence by Pythagoras theorem AC equals 5k. 3k, 4k, 5k are also the Pythagorean triplets. Now I can take the same ratios like sine ratio, cos ratio and all. So what is the ratios? Here I'll write. Wherever I have written red is pertaining to that part. What is the sine A now? T ratio. Sine A equals opposite by hypotenuse, that is BC by AC. What is BC? 4k divided by 5k. K cancels, which is 4 by 5. Check the answer. Sine A equals 4 by 5. Sine A equals BC by AC, 4k by 5k, and therefore 4 by 5. Final answer will not change. We cannot get final answers in terms of k because in all the ratios, k being a positive number, it will get cancelled because it is multiplied with all the sides, and as these trigonometric ratios are the ratios of the sides, in every ratio the positive constant here k will get cancelled, and finally we get the trigonometric ratios in terms of the ratios of some numbers. Is it clear? So this is sine A equals 4 by 5. Cos A equals adjacent by hypotenuse AB by AC. AB by AC, which is 3k by 5k. K cancels, which is 3 by 5. 3 by 5. Similarly, tan already done, and therefore we go for cosec. Cosecant. Cosec A equals AC by BC, which is the reciprocal of sine, and therefore this is 5k divided by 4k, which is 5 by 4. And sec A is the reciprocal. Sec A is the reciprocal of cos A, and therefore this is AC by AB, which is 5k by 3k. K cancels, which is 5 by 3. And finally cot A is the adjacent by opposite side AB by BC, which is 3k divided by 4k, which is 3 by 4. 3 by 4. So this is how we end up of finding all the ratios. Now which method is preferred and which is not preferred? There is no comparison as such. This is the textbook method which you can follow very well, or textbook method, very important. Some students are not comfortable really by taking the ratios in terms of k. See here, this k is nothing but, say, if angle is in the ratio of 4:3, if two angles are in the ratio of 4:3, then how normally you used to take it? 4x and 3x, isn't it? So similar to that here, k is the one which you are considering as the ratios. K is a positive number, and the ratios are generally expressed in terms of some variable. K is a positive number means actually here it is a variable. A k can be a real number, but it should be a positive because we take a positive over here, so that the signs will not change at any cost. Even if these signs change over here, the k value will not change, and the total value will not change, and hence we consider as a positive number. Also it is called a constant. Simply you can call this k as a constant. Something like, the ratios. If two angles are in the ratio 4:3, then we used to take the angles as 4x:3x. Similar to that one, 4k:3k is the ratio of the sides. Okay, so this is how we can solve by two methods. Now henceforth, hereafter, I may consider sometimes in terms of the k, or I may take directly the ratios in terms of units and proceed with solving the numericals. But both methods are equally good. I have discussed both for you. It is up to you to define. As I said, some students will not feel comfortable by taking k or x. It can be anything, because you are going to get under root over here. Here it's under root of k square will be there all the time, and that comes out as k. And therefore, if you are not comfortable with k, leave it. There is absolutely no issue with that. Fine, students, make a note of this one. Next, I will go to the second numerical. Here we will take one R.D. Sharma numerical. In right triangle ABC, right angled at A, if AB equals 12, AC equals 5, find all trigonometric ratios. Without drawing the diagram, we should never proceed this, very important. So let me draw the diagram over here. So right triangle ABC is given to us. Solution. This is right triangle ABC and right angled at A, and therefore this is A here, right angled, and this can be B and this can be C. Given information is AB is 12 and AC is 5, AC is 5, and find all trigonometric ratios. Sometimes the diagrams will not be true really according to the dimensions. Here AB appears to be smaller here, AC is bigger in the diagram, whereas the given information is something like this. So what I will do here is, in order to follow with respect to the given dimensions and true representation, let me change this, reverse this one, B and C. See what happens now. B and C. Now, correct now? So AB is 12, which is bigger and therefore bigger side, and AC is 5. Now it's okay, approximately. It's only a true presentation, that's not exact representation, but nearer to the real situation, I can say, that's all. Okay. AB is 12, AC is 5 units. Find out all trigonometric ratios. First I should know right angled at A, AB is this. Find trigonometric ratios with respect to which angle? Ratios of angle B. Find trigonometric ratios of angle B. This is the question. So with respect to this angle, I have to find out. It's okay. Let me mark this as a reference angle B and find out first the hypotenuse here. Solution. By Pythagoras theorem, BC square equals AB square plus AC square (12 square plus 5 square) 144 plus 25, which is 169, and therefore BC equals under root of 169, which is 13. I got BC as 13, which I will write it here. So 5, 12, 13 are also Pythagorean triplets. With reference to B, I have to find out all the trigonometric ratios. So T ratios of angle B, sin B. See here, very important. Adjacent to this angle B is adjacent side and this is opposite side. So for your information, I'll write here, this is adjacent side, and this is opposite to B, opposite side, and this is hypotenuse, H I'll write. It's only for your information. We need not mention all these things, but there is nothing wrong even if you mention. But sometimes they may ask you to find out sometimes sin B over here, sin C over here. In that case, these things will be interchanging, and hence we may not use that one. So as and when you practice more and more numericals, you need not mention the adjacent side, opposite side and all. Immediately you should be able to visualize and represent it in the form of the ratios of the sides of a right triangle. Okay, so sin B equals opposite by hypotenuse. Opposite by hypotenuse. Sin B equals AC opposite by AC by BC, which is 5 by 13. Cos B is adjacent by hypotenuse, AB by BC, 12 by 13. Sin cos tan B is opposite by adjacent side, AC by AB, which is 5 by 12. 5 by 12. Once you know these three ratios, next cosecant, secant and cotangent are the reciprocals of this one. So cosec B is hypotenuse by adjacent side, hypotenuse by opposite side, hypotenuse by opposite side, which is BC by AC, which is 13 by 5. Sec B, secant B, which is reciprocal of cos, BC by AB, that is hypotenuse by adjacent side, BC by AB, 13 by 12. 13 by 12. Next, cot B is adjacent by opposite side, which is AB by AC, 12 by 5. So these are all the trigonometric ratios. So sin B is 5 by 13, cos B is 12 by 13, tan B is 5 by 12, cosecant B is 13 by 5, and sec B is 13 by 12, and cot B 12 by 5. So these are the answers. Now according to the textbook, you can consider over here AB equals 12K also you can consider, but as it is, the problem does not mention about any K or X and all, so directly I have taken over here. If sometimes they give the trigonometric ratios like sin A equals so and so, find all other T ratios, in that case I may consider K also. Okay, let's go to the next numerical now. I'll continue. I think I'll continue. So find B, sin B, cos C, but I'll take something little different. I'll take few numericals from the textbook now. Yeah, example number 3 I'll solve. Textbook example number 3. We'll solve here only. Textbook. Example 3. What is that? It will read. Consider triangle ACB right angled at C, in which AB equals 29 units, BC equals 21 units, angle ABC equals theta, and determine the values of first one cos square theta plus sin square theta, second one cos square theta minus sin square theta. So this is example 3. What is given is triangle ACB is given to you. This is what it is given to you. ACB right angled at AC, and AB is 29 units, AB is 29 units, and BC is 21 units, and angle ABC is theta, angle ABC is theta, this angle is theta, it is given to you, and we need to determine in this case first one sin square theta, cos square theta plus sine square theta, and second one cos square theta minus sine square theta, cos square theta minus sine square theta. This is what is to be determined. So solution, okay, by Pythagoras theorem, if I know side AC, then it is easier for me to find out all these ratios, because sine, cos, tan, all these things involve the opposite side also, and therefore of course sine involves opposite side, and therefore I need to find out side AC by Pythagoras theorem. AC square equals, or AB square equals, I'll write AB square equals BC square plus AC square, 29 square BC square 21 square plus AC square, and therefore AC square equals 29 square minus 21 square, which equals 29 plus 21 into 29 minus 21. I can use this formula also, A plus B into A minus B. I can use this one, and therefore AC square equals 9 plus 1 10, carry up 2 plus 2 4 1 5, 5 0 plus 29 minus 21, 29 21 8, not plus into, okay, into 8, which equals 400, and therefore AC equals under root of 400. How do you find out? Under root of 400. 4 into 100. 4 comes out as 2, 100 comes out as 10. So 400 is nothing but 20. Correct? 2 into 10, that is 20. So we got AC here as 20. I will mention later on. AC equals 20 units. Simply mention AC equals 20. So first one, let me clear this board, or I'll write here. That's okay. I hope you are able to understand now. First one, in order to solve this one, you can find individually and substitute it, or directly you can substitute the values and write it. So I am taking directly over here. First one, cos square theta plus sine square theta equals, what is cos square theta? One more thing I just wanted to tell you here. Here, whenever the squares of some trigonometric ratios appear, very important, you must note here itself I will explain that one, important. See, all trigonometric ratios, sine theta the whole square equals sine square theta, or implies this way. Sine square theta means sine theta the whole square. Cos square theta means cos theta the whole square. You understood? For example, if I write cosec square theta or sec square theta, sec square theta means sec theta the whole bracket square, sec theta the whole bracket square. So sec theta ratio we know, and the whole bracket square will be the ratio of sec theta the whole bracket square. So here cos square theta means cos theta the whole square. Here I am writing for your information, but henceforth in future I may not write in detail all those things. I hope you are able to understand with respect to the squared relation over here. Okay, so cos square theta means equals, I will write here, which equals cos theta the whole square plus sin theta the whole square, which equals, what is cos theta? Cos theta is adjacent by hypotenuse, which is adjacent over here. This is theta here, this is adjacent over hypotenuse, 21 by 29 the whole square. So cos theta is equal to BC by AB the whole square, BC by AB the whole square, plus sin theta is AC by AB the whole square, opposite by hypotenuse, AC by AB the whole square, which equals, what is BC? 21 divided by AB, BC by AB, AB is 21 by 29, 29 the whole square, plus AC 20 by AB 29 the whole square. So how do you solve this one? Which equals 21 square divided by 29 square plus 20 square by 29 square, which equals 29 square, okay, 21 square plus 20 square, 21 square plus 20 square, which equals 21 into 21. We'll try to solve this one now. This is nothing but this entire ratio, value of this ratio will be, how much is 21 square? 21 into 21, this is 441 plus 400 divided by, you have to remember all this one, 29 square. 29 square will be how much? 29 square, 29 into 29, which is 841. So this is 841, which is 841 divided by 841, which is 1. So we got cos square theta plus sin square theta equals 1. Of course, this is an identity also which will be proving in our further when we solve the numericals, or when we discuss the section of solving the numericals based on identity. So we have solved cos square theta plus sin square theta. What about cos square theta minus sin square theta? Somewhere here itself I'll try to solve, or I'll clear the board over here. You can note down this. Let me clear the board here. Which one now? Second one. Cos square theta minus sin square theta. Second one. Cos square theta minus sin square theta equals cos theta the whole square minus sin theta the whole square. Okay, what is cos theta? Already we have BC by AB. BC by AB the whole square minus sin theta AC by AB the whole square, opposite by hypotenuse the whole square, sin theta. So what is BC? 21 by 20 the whole square minus AC by AB 20 by 29 the whole square, which is 21 square by 29 square minus 20 square divided by 29 square, which is 29 square. Now what is 21 square? 441 minus 400, which is 41 divided by 29 square, 29 square, which is 41 divided by 841. I think this is what the answer is correct. So this is how you should be able to solve some of the numericals. So make a note of this one. I will take up a few more numericals from textbook or R.D. Sharma. It is going to be a combination of both, and let us say based on the level of complexity I will be picking up randomly from textbook as well as for revision. Now what I will do here is let me go to the exercise now, okay, and I try to solve some numericals from the exercise. I think that makes sense also. Okay, note it down. Let us solve another two example numericals and then I will go to exercise. Textbook example number 2, I think example number 2, correct? If angle B and angle Q are acute angles such that sine of angle B equals sine of angle Q, then prove that angle B equals angle Q. Here I am considering two triangles. So solution, consider two right triangles, triangle ABC, because angle B is an acute angle, and triangle PQR where Q is acute angle. Okay, so let us draw the diagrams now. Triangle ABC, B should be acute angle. So this side I'll make it. This is triangle ABC. You can make like this, or you can make it A this also. But anyway, I have to made acute angle as this reference angle is B here, and therefore I have brought it on the right hand side. So ABC PQR. Similarly, I will consider like this, PQR. Okay, these are the two triangles that we have considered. In this one given, sine of B, this is right triangle, okay, very important, right triangle at C and right triangle at R. Sine B equals sine of Q, implies sine of B is opposite by hypotenuse, AC by AB, sine of Q is PR by PQ, PR by PQ. Now what I will do here is I will interchange this one, AC by PR, AC by PR in terms of cross multiplication, something like that, AB by PQ, AB by PQ, AC by PR equals AB by PQ, AC by PR equals AB by PQ. This is what I have written, okay. Also I can consider this to be a K now. What is that? This is to be K, which equals K. What is this K? Where K is a constant, where K is a constant. Say I can write something like this also. Let AC by PR, AB by PQ. Let AC by PR equals AB by PQ equals K also, or maybe this is okay, whatever this I have written is okay. Now AC by PR equals AB by PQ equals K I have taken. Why can't we find BC and QR in these two triangles? Now by Pythagoras theorem, in triangle ABC, BC square equals AB square minus AC square, AB square minus AC square, AC square. And also in triangle PQR, in this triangle PQR, QR square equals PQ square minus PR square Now what we will do, BC by QR square, BC square by QR square we will take. Now BC square by QR square equals BC square by QR square equals AB square minus AC square divided by PQ square minus PR square, which equals, what is AB? Can we express AB and AC in terms of PQ and PR? Yes, it is possible. See here, AC by PR equals K, and therefore AC equals PR into K. So AC equals PR into K. This is how we can get it. Or you can do one more thing. Here itself I will mention here, implies AC equals KPR, K times PR, and AB equals K times PQ, K times PQ, and this you mark it 1. AC equals, I hope you are able to understand clearly, AC equals K times PR and AB equals K times PQ. So entire this statement I am tracking it as 1, and therefore here I will mention what is AB square. AB square is KPQ the whole square, KPQ the whole square, minus AC square is KPR the whole square, KPR the whole square, the whole divided by PQ square minus PR square. Reason from 1, that is from 1. Now this equals K square PQ square minus K square PR square, the whole divided by PQ square minus PR square, which equals K square into bracket PQ square minus PR square, the whole divided by PQ square minus PR square. So this and this will cancel, which equals K square. This is nothing but BC square by QR square is equal to K square, which implies BC by QR equals under root of K, which is K. So this is how we proved here. Now from here AC by PR is equal to AB by PQ equals K. Finally BC by QR equals K. I think tagging and tracing a little bit I could have fine tuned, it's okay. Now from this and from this, can we say AC by PR equals AB by PQ equals BC by QR equals K? Therefore AC by PR equals AB by PQ equals BC by QR. Okay, this is how I can say from this and this. Or if you want traceability to be changed, maybe I can mention this as 1, this as 2, little bit, just a moment, I'll make this as 1, this as 2 here, and therefore this is from 2, I'll write from 2, I'll write. So this is from 1, this is from 1. BC by QR is equal to A, therefore AC by PR equals AB by PQ equals BC by QR equals BC by QR from 1. From this and this is what finally true. What is the meaning of this one? Check the diagram. AC by PR should be equal to BC by QR finally, and AB by PQ, meaning these two triangles are similar, isn't it? Therefore triangle ABC is similar to triangle PRQ. ABC is similar to PQR. By what? Triple S similarity criterion, because these are the ratios of the corresponding sides of this two triangle, which equal constant basically, and hence these two triangles are similar by triple S similarity criterion. By triple S similarity criterion. And therefore angle B equals angle Q corresponding angles. Therefore angle B equals angle Q corresponding angles. These are not corresponding angles of parallel lines and transversal. In these two triangles B and Q are corresponding angles because these are similar over here. So note on this sum, which is important, and only the problem statement will be without the diagrams, and therefore drawing the diagrams and solving is very important. And many times you can expect this question: when sin B equals sin Q, make sure that we need to draw the two triangles separately, and finally you prove that the two triangles are similar, and therefore angle B will be equal to angle Q. This is what we could prove it. So make a note of this one. One more typical example, example number 5. In triangle OPQ, the diagram is given. Right angled at P, OP equals 7 centimeter and OQ minus PQ equals 1 centimeter. Find sin Q and cos Q. In order to find out the sin Q and cos Q, I should know all the three sizes of the triangle OPQ. Only in that case it is possible to find out sin Q and cos Q. And therefore, with the given information, let us try to find out the three sides of the right triangle. So let us see how to solve this one. Solution. Given OP equals 7 centimeter, OP equals, and OQ minus PQ equals 1 centimeter, implies OQ equals 1 plus PQ. So what is OQ? Here I will write 1 plus PQ centimeter. You got it? And this is PQ. If I apply Pythagoras theorem, only unknown will be PQ. Therefore, I should be able to get the value of PQ. If I know PQ, I can definitely find out OQ. Plus 1 it is. So, now by Pythagoras theorem, OQ square equals OP square plus PQ square. What is OQ? OQ square. OQ square is nothing but 1 plus PQ, the whole square, equals OP square is 7 square plus PQ square, as it is PQ square. Expand it. 1 plus PQ square plus 2 times 1 into PQ, which is PQ, equals 49 plus PQ square. This side and this side PQ square will cancel. Therefore, 2PQ equals 49 minus 1, which equals 48, and PQ equals 48 divided by 2, which is 24, and therefore PQ equals 24 centimeter. Mark it 2. So PQ equals 24 centimeter, and therefore I'll write OQ equals 24 plus 1, which is 25 centimeter. This is third here. This is 25 centimeter. I found out all the three sides, and therefore now sine of Q. Sine of Q. What is this angle? Q here. Sine of Q means this is opposite, this is hypotenuse. Opposite by hypotenuse. OP by Q, OQ. OP by OQ. OP is 7 centimeter divided by OQ is 25 centimeter. So sine Q is, we have found out, cos Q. Cos Q is, cos of this angle is adjacent side by hypotenuse. PQ by OQ. PQ is 24 divided by 25. This should be your answer. Let us check the answer now. Yeah, sin Q is 7 by 25. Sin Q is 7 by 25. Cos Q is 24 by 25. So make a note of this one. Yes, students, I think couple of important numericals I have solved. Example number, this example and previous to that one. So make a note of all this one. Exercise 8.1 I'll be taking up few numericals from exercise 8.1 I'll be taking up in my next lecture. For the time being, let me end this lecture over here and see you in the next class, that is in the next lecture. Thank you very much for watching.